In this lesson, we're going to take what we've learned in the last few lessons and apply it now to solving equations. We can see how it helps us solve some things we couldn't necessarily solve before. But first, we're going to look at some, I think, simpler examples that will show how we can solve these exponential equations. So, um, just in general, if you had a to the x is equal to a cubed, because these two have to be equal, if you had to solve for x, you would know that x is equal to 3, because for these two bases to be equal, then their exponents would also have to be equal. So for this problem over here, um, we don't have exactly the same situation, but we can turn 16 into 4 essentially by giving it an exponent. So we have 4 to the x plus 2 power. We're trying to solve for x. And we know that 16 is 4 squared. So now we're trying to get that in the same base. And that's still to the x minus 3 power. So now, remember, if I am taking a power to a power, I multiply the two exponents. So I still have 4 to the x plus 2 power. But now I'm going to multiply 2 times x minus 3, and that's going to create a distribution problem, essentially. And I have 4 to the x plus 2 is equal to 4 to the 2x minus 6. So now I know that this exponent has to be equal to this exponent. So I can come down here and uh, make this x plus 2 is equal to 2x minus 6. And then it's just algebra that you're familiar with. So we'll subtract x from both sides, add 6 to both sides. We get 8 equals 2x. So when we divide by 2, we get x is equal to 4. So that's how you would go about solving kind of one-to-one problems such as this. So let's look at one involving fractions. We know that 81 breaks down into 9 and 9, which each breaks down into 3 and 3. So essentially 81 is 3 to the 4th power. So we can rewrite this as 1/3 to the n power equals 1 over 3/4 to the 2/3 power. And remember that we can rewrite these fractions as negative exponents. So I can say 3 to the negative first power to the n power equals 3 to the negative 4th power to the 2/3 power. So now I can, since I'm taking a power to a power, I can make this 3 to the negative n power is equal to 3 to the negative 8/3 power. So now uh, I know that this has to equal this because they have the same base. So negative n equals negative 8/3. That means that n has to equal positive 8/3. So go ahead and try this problem. We have 25 to the x plus 2 power equals 5 to the 4x power.